Welcome, scholars, to Mr. Honeycutt's math class. Today we're working on finding the intercepts and asymptotes graphically, numerically, algebraically. Today's going to have a lot of content. Much of it you've seen before, but of course it's me, so we're going to push everything up to a far higher conceptual level. So I want to make sure you have a deep conceptual understanding of x and y intercepts and vertical and horizontal asymptotes and how to find them, what it means, things like that. So these topics appear all the time on the ACT, and they do appear sometimes on the IB exam. So please take notes for this whole thing. So we're starting just with y-intercepts because that's the easiest one. Now, first off, let's review what a function is. Okay, so we can think of a function as a machine that takes inputs and outputs. Okay, so the x, in this case, doesn't just mean x, it means it's an input, and f of x does not mean y, it means an output. And remember, does not mean that we're multiplying a variable f times the variable x. It's actually function notation that means the input equals the output. Okay, so just kind of review. So what this matters for intercepts is our input or output is a 0. That's what causes graphical intercepts. All right, I like starting with the graphs because I think you guys are more visual. So if you can get to the visual, you usually do okay. So that's kind of the base thing. But you need to be able to jump between the conceptions, hence the graphical, numerical, algebraic. You need to become multilingual in your mathematics. So intercepts is when the input or output equals 0. For the y-intercept, that means that's when we're inputting 0. When x equals 0 or t equals 0, whatever our input variable is, that's when we're inputting a 0. Okay? X-intercepts are going to be caused when we output a 0. Notice that there's sort of I think this is where most students get confused with this, because it's a y-intercept and it has something to do with a 0. You might think that means that y equals 0 at that point, but it's in fact that x equals 0, because x equals 0 on the y-axis, or there's that counterintuitive thing. Same thing with the x-intercepts. You might think it has something to do with it when x equals 0, but no, it's when y equals 0. So there's sort of a counterintuitive thing, but think through what that means graphically. Okay, so just to remind you, like y-intercepts, tell us what the initial value, sometimes called the initial conditions, are. The starting value, the value at t equals 0 or x equals 0. So if a question is asking you, say, for an initial velocity, an initial acceleration, an initial anything, a starting profit, starting expenses, something like that, that means you want to find the y-intercept. You want to find whatever that function is at 0. That's why it's important. And in fact, in more advanced mathematical modeling and chaos theory tells us that initial conditions are incredibly important. And in fact, are often the determining factors for all sorts of things. So yeah, graphically, what's a y-intercept? Well, when your x equals 0, that'd be there. This is the y-axis. That's where the y-intercept is, okay? And that's for just a simple linear function. For a more complicated function, hey, notice it's when the x equals 0, it's on the y-axis, there is the y-intercept. Notice that you can only, with functions, you can only have one y-intercept. You might have multiple x-intercepts, but you're only going to have one y-intercept, which makes sense. You're only going to have one starting place, all right? So numerically, if we've got a chart of numbers, it's again when x equals 0. So when the x, if we're going to hey, what's my x equals 0? Well, then my y-intercept has to be 3. When is my x or my t or whatever equals 0? Then, all right, my initial condition, my starting place in this case is -2. Okay? Those are numerical ways of viewing these. Moving along, I'm not really sure what happened to this slide, but algebraically, if we want to find a y-intercept, we're going to substitute in a 0. So instead of x's, we're putting the big empty parentheses, and then we're going to plug in the 0 everywhere. When we do that in this case, you get 0 squared minus 0 minus 10. So your y-intercept in this case is a -10. So now we could have jumped ahead to see that it's just -10, but you need to be careful with that, because sometimes the things that have variables, if you're dealing with a polynomial, you can just find the last term, the constant term. But if you're dealing with anything basically other than polynomials, you need to actually plug it in. So that's it. That's how to do like y-intercepts, what they mean, how it all works together.